This video demonstrates the core functionalities developed by OwnYourData in the course of the FFG-funded project IDunion. To cover all data portability aspects of an electronic vaccination record, we created 3 data flows to demonstrate solutions for specific administrative and technical challenges. Creating a verifiable credential, checking the proof of a verifiable presentation, secure and trackable sharing of personal data. We demonstrate creating a verifiable credential for the booster shot of COVID-19 vaccination in the first data flow. First, the doctor logs into the semantic container using the identity maintained on the IDunion network using Isato's SOWL platform. In the doctor's office, a QR code is put on the wall that provides information for users to request information about the vaccination and how data is handled. From a user's perspective, the process starts now by scanning the QR code with the OwnYourData smartphone app, reviewing the provided information. The form is automatically populated with data from the personal data store, and the user can send the information to the semantic container of the doctor. The doctor has now a new vaccination application available and can review the provided information. Relevant additional information like dose number and duration of the certificate's validity is entered. With all information available and verified, the doctor performs the vaccination and triggers the creation of a verifiable credential by clicking Vaccinate. The user receives this verifiable credential in the Isato's wallet and accepts it. The system automatically generates provenance information using W3C provenance ontology, and it can be visualized in the semantic container. Afterwards, the semantic container archives the information and also sends a copy of the COVID-19 credentials in the format defined by the World Health Organization together with all metadata to the user's personal data store. This includes a provenance trail from creating the verifiable credential and allows to transform the credential into other formats using the semantic overlay architecture. For the second data flow, we demonstrate the verification of the vaccination status at a reception of an employer. In this use case, the user maintains the verifiable credential in the Isato's Wallet app without a dedicated account of a personal data store. First, the receptionist logs in to the semantic container using the identity of an authorized verifier. When an employee enters the office, the verification process is initiated by sending a request to the user's wallet. In our configuration, the wallet is configured to automatically respond to such a request. A log entry in the Isato's wallet documents the response. The receptionist verifies the received proof of vaccination provided by the wallet and makes a final decision to admit or decline entry. The semantic container documents the complete progress and generates a cryptographically secure audit trail. And finally, we demonstrate secure and traceable data sharing between an individual and an organization in the third data flow. Utilizes a semantic container to store a survey and associated usage policy and a participant list. The survey is initiated by sending out emails to all listed participants. Each participant receives an email containing a link to access a data sharing plugin for the personal data store, where they can review detailed information regarding the survey. Each user then fills out the survey and selects some accompanying data. When the data is shared, a unique digital watermark enables unambiguous identification throughout the data lifecycle. The organization manages all server responses in the semantic container and can automatically process GDPR information requests or requests from the user to revoke previous consent instances.